This conference will now be recorded.
Hello all, good morning, good afternoon. Welcome to today's session of Vivit Toronto User Group on Smarter Testing Superior Outcomes. This event is sponsored by Microfocus and Toronto Vivit User Group. My name is Vijay and I'm a project manager at TechMahindra. Next slide please, Brian. My name is Vijay and I'm a project manager at TechMahindra. I lead the performance testing and engineering projects of Scotiabank Canada. I'm also a member of Vivit Toronto Local User Group and a leader. We appreciate you joining us today and hope that you're all safe and healthy. Next slide. This live session is being recorded and posted for all Vivit members. The on-demand recording, slide deck, and question and answers will be posted on the Vivit page under the Toronto LUG's group page. You can find this by going to the groups dropdown and search for your appropriate group. We'll send you a link via email once everything is posted as well. A little housekeeping. We really want to make this event interactive and welcome your questions. However, when you're not asking a question, I request you to please mute your microphone. If you join via phone, please enter your audio pin in order to link your phone call with your GoToMeeting control panel. This allows you to mute and unmute yourself using the audio button rather than your telephone keypad. And it also ensures other participants will be able to see when you are speaking if you wish so. We'll be sharing the way to redeem your lunch coupon at the end of the session. Shown here is a picture of the GoToMeeting control panel. Although yours may look somewhat different, you will still see the same icons. To submit a question, click on the dialog box icon in the upper right-hand corner of your screen and type your question. Or we welcome you to personally ask your question by coming off mute, and you can also show yourself on the webcam if desired. To do this, click on the camera icon found in the middle bottom of your screen or on the left side of your control panel. For those of you that are joining and are not a Vivit member, can you please go to the next slide then? For those of you that are joining and are not a Vivit member, I wanted to share with you what our community is all about. Vivit is an independent, not-for-profit service organization that represents the broad microfocus community globally and is the endorsed microfocus software users group. Vivit's mission is to serve the microfocus community through advocacy, community, and education. For almost 2 decades, Vivit has been the unbiased, trusted, and field-tested user community for thousands of HP and more recently microfocus software customers. Through acquisitions, our scope has expanded from our original focus on OpenView to include Mercury Interactive, Freshwater, and Vertica customers, developers, and partners from around the world and from all areas of business and industry. With the merger of the HP software and microfocus business, once again, we are here to help our members attain the maximum benefits from their investments in microfocus software. Nearly 39,000 members worldwide in the Vivit user group, and we have 84 LUGs in 30 countries, 21 SIGs, Vivit members located in 159 countries. Vivit is not just for practitioners, but managers and executives too. 50% of the members work hands-on with the microfocus products. 50% of members are in decision-making roles. If you are not a member already, I would suggest you to opt for it. Next slide, please. Let me introduce you to today's speaker, Brian Cole. He is the ADM Practice Manager Americas. He is responsible for ensuring that the customer-facing sales team that have all the technology and knowledge required to execute their job function. With over 20 years of experience in the quality assurance space, Brian has extensive knowledge of the challenges faced with the construction and delivery of software in a DevOps world. He lives in Toronto, Canada, is an avid student of history and an idealist on through. So I'll hand it over to Brian now, and he would speak about the smarter testing, and he'll take it forward. Thanks, Brian.
Thank you so much, Vijay. Welcome, everybody. As always, if you do have questions at any point, please feel free to type them into the chat. I can see that on my other monitor. I will address those in line as they come in. You can also go off mute, and as Vijay said, if you do come off mute, please put yourself back on mute. Otherwise, it starts to get a little hard to hear everything. So why do people keep talking about things like release velocity or DevOps or any of these other terms, right? And it's really fundamentally, how do we get things from dev to ops? There's a world of complexity underpinning this concept. I freely acknowledge that. But when we look at the time that is spent doing the work and the time that is wasted waiting for other people to pick up that work or to transition it from one team to another. These are where a lot of the friction in a DevOps delivery process gets introduced. And this is really what DevOps conversations are about, is automating away these manual wait times and manual tasks and making it a fully autonomous process to go from dev into operations. Lots of complexity in there. We're really focusing today on the fundamental problem of the outcome of this process. As the development teams dramatically accelerate their release velocity, and we've certainly seen this inside Micro Focus, we find that the downstream impact on other teams begins to start to become a problem. So you can see it here. If the time spent coding, then getting it into unit test, and then validating security, and then doing integration testing dramatically speeds up, all of that work throughput begins landing faster and faster onto the functional testing teams themselves. And they simply cannot, under the old style of test automation, keep up. We see a number of different pushes on this front where the development community says, let us just do the testing. And there are good reasons why they should be doing testing. There are good reasons why you want another group to do testing as well for an independent QA. There are any number of mechanisms in place that you can use. There's no one right answer, but fundamentally the engines have to change. And what the process looks like when we talk about this, I have a series of developers here, and they are leveraging a very conceptual DevOps toolchain. When they build software and deploy it into the version control system, the CI engine will see that, build that artifact, tell a delivery server, ideally, what to do at this point. It will go and fetch that artifact and then deploy it into a development environment. And critically, tell the CI server that it finished that task. This is the point in the DevOps toolchain where you should be executing tests. You can't run a test against just the software source code. You can't run a functional test against the setup.exe or the war files. You have to deploy the running version of the application first. Once that's done, you begin executing your tests and then collect all this information from the multiple different environments as it rolls through these autonomous processes to get it into a production environment. Doing that and figuring out how to do that with functional testing is increasingly challenging due to the velocity increase and how quickly the turnaround time needs to be. And as developers know, you are constantly changing things, tuning things, adding additional features and capability, which means those functional test assets break. They no longer reflect what the application is doing, whether that's from introducing new functionality that needs to be incorporated into the scripts. I don't have a solution for that. There's no workaround there. That's what the QA teams are for. Or whether it's more prosaic things where the object properties change. And that's going to be one of the things that we address today. So what is artificial intelligence, right? Artificial intelligence is a very big conceptual space, and it is really talking about making machines capable of decisions. And there is a lot of different ways of doing that. We're talking about machine learning in this case, which is training the software to perform simple tasks as well as complex ones. It is really nothing more than an elaborate pattern matching algorithm. It's incredibly elaborate, and it works very similar to how human brains work. We'll talk more about that later. But basically, I give it some inputs, and it compares those to what it thinks the outputs should be and gives me a result at that point. And we're seeing artificial intelligence conversations cropping up in a wide variety of industries, whether that's analyzing MRI scans and doing so better than medical professionals, whether it is the conversations around self-driving cars, whether it is the idea of chatbots and autonomous online customer support. We're starting to see this interact in a wide variety of areas that are out there. The key is to do it in a nearly real-time fashion. Using the car example, it does no good to correctly identify the stop sign 10 seconds after you've passed the stop sign. You need to be able to do this very, very quickly and accurately in all scenarios. So why are we talking about that here with functional testing? So the traditional sort of role for how functional testing works tend to fall into three distinct styles of teams. There are the coded dev testers themselves. They tend to focus very much on the IDE, whether that's Eclipse or IntelliJ or Visual Studio. They write JUnit and NUnit tests. This type of crowd really likes the Selenium tool set, and it's great, and they should continue to leverage that. The traditional testing audience, this is really where we talk about the automation engineer, the traditional user of unified functional testing, excuse me. And then there are the business analyst domains and the domain experts. Those individuals tend not to have the technical skill set, but have all of that business logic and analytical skill about how the application works, how the business process needs to work, and they need a set of solutions for them as well. So there are a number of challenges that come out of this, right? As that release velocity increases, we cannot simply just create tests the same way that we always have. There are cascading changes coming down the line, and we can't update the test and run the test against that old version, because by the time we've updated the test, 2 additional versions have arrived. We can't keep up. We have to do something different. And this leads to historically relatively low automation rates. We tend to see automation get implemented on parts of the application that have gone into kind of a feature hardened state, where there's no new work being done on these parts because they're largely done, which negates some of the value. Certainly we're catching regression issues, but we're not really being able to be a meaningful contributor to the actual pipeline and delivery conversations that are taking place. But that's not to say that we aren't trying, and that leads to a lot of high maintenance as object properties tend to move all over the place and UI design changes tend to break script assets. So using today as an example, we need to create an automated process to buy something from an e-commerce application, right? So you have to log in, find the item, add it to your cart, do the purchase. But there are multiple different avenues that we can pursue, whether that's Android, iOS, or the web. And that means that we now need 3 different scripts to automate this flow, because the object properties from an Android device to an iOS device to mobile web are just different. They're not consistently the same, let alone the full web desktop as well. So now I have 3 different scripts. If there is a change to the application that impacts all of those scripts, I have to change those 3 things. And this is where we get into these arguments about, do we actually get a return on investment? Is there value in an automation effort in this arena of high change? So something's got to give. So let's talk about how things work in the traditional sense, right? So this is a very typical UFT script. It's going to play back against a mobile device over here. You can see it moving through. It's going to interrogate the objects, click on the profile button, type in the username and password, and log into the system. And everything is going to be great. This is a traditional sort of UFT script. This is how the product works. Very common environment for a lot of people, right? Everything's good on this front. So what happens now if we make a change to the application? So we go in and we're going to go in here and see that, oh, I think, there we go. So now we're going to make a change. We're going to switch the menu and the shopping cart. You can see they're just switching position. And we're not really adjusting the object properties under the covers for this. We're deliberately doing something that's going to cause UFT to misidentify things and fail. So when we go into the second go around and play this script over here, what we're going to see is it goes through the same process. Go to the application, tap that, when it reloads it, you'll see the menus have now switched. It loads the shopping cart, which is not what we wanted. And then we get this sort of dialogue. And anybody who's used UFT has seen this many, many times. Certainly I've seen it more than 10,000 times, it feels like. Something's wrong with my script. I have to go into triage. My error handler might need to kick in. I have to start diagnosing what happened. It looks fine from what I see on the error dialog right here. I need to actually go into the full test flow and look at previous steps. There's just a problem with my test asset at this point. So why that's happening is the object properties were different. This is the common use case, right? What if we could do this like a human being does it? Because if I had asked you to go and click the profile button, you would be able to find the menu without worrying about whether it had shifted to the other side of the screen or not. You would just recognize it for what it is. And that's really what we're talking about. There are a lot of major areas for artificial intelligence research. We are really focused on these 3. So the perception side of it, this is really around computer vision. UFT actually has tremendously good engines at recognizing things on the screen today and understanding what's going on. And we are screen-based. We're not going to try and get out into the real world like an autonomous car would. But this is where we're making all of the innovations that I'm about to talk about. This is where we've put in these learning models to really change fundamentally how UFT works and how you can take advantage of this to dramatically simplify your lives and environment. So what are we talking about? So what do we see, right? Most of the time when I'm doing these presentations, people would say, I see 3 dogs. And I would say, yes, I see a dog, and a cool dog who's got his sunglasses on and his fur is waving in the breeze and he's just enjoying life. Everything is good. And then we talk about, what do we see here? And most of the time the audience is like me and they say 3 cats. And the actual answer is, we see a cat, and a cool cat. And there's always somebody who will play along and say, yes, I see the cool cat because he's got the sunglasses on as well. He's got his little bow tie. He's ready for a formal event. Everything's good on this front. But something amazing actually happened there, because I gave you pictures of a dog and classified them for you, saying the dog with sunglasses is a cool dog. And then I showed you pictures of cats, a totally separate entity, one of which had sunglasses on, but they were a different type of sunglass, and you correctly were able to classify that as a cool cat. And this is what a neural network does. This is what we do as human beings all the time, because we have neural networks that run in our brain. Brain chemists and neuroscientists think somewhere between 15 and 40 billion different neural networks that govern every part of what it means to be human, whether those are fully automatic that we're born with that regulate things like heartbeat, or whether those are things that are learned, like the ability to walk or grasp things or do mathematics or talk. These are all different neural networks that we have formed in our brains that will allow us to function. They are created through a process of learning. This is what learning is all about, right? This newborn cannot distinguish between a cat and a dog, but by 1, they probably know how to do this task. And this is because they've had a supervisor providing examples and teaching corrections to that. No, that's not a cat, that's a dog. No, that's not a dog, that's a cat. No, that's not a cat, that's a car. And going through these processes to teach them what is what, and then they begin to form their own neural networks to get this going in place. When we talk about these examples, though, more relevantly to the types of problems that UFT interacts with, what do we see here? And the answer is, of course, these are all login pages. We can all immediately identify that, even though this one says sign in, even though these are both Office 365, UFT might see both of these as very different applications using traditional object recognition, because they are one in a mobile form factor and one on a web form factor. And the object properties are just different. This is just how applications tend to be built. So if we can identify this as all fundamentally exactly the same thing, why can't computers do this? So now we're talking about what we've done with UFT. And this is where we talk about how deep learning has really been on the rise since the 2010s or so. This is because of the combination of big data accessible on the internet and a dramatic increase in computing power that have been available as well. The way this works is, and I'm not going to go into how neural networks are created or anything along those lines, but there is a tremendous amount of effort that goes into building these things out, and they are created by the computer system itself. They don't tend to have a specific sort of view of the world or anything along those lines. They get put together by the machine. And the neural networks inside of UFT are maybe 130 layers deep at this point. It's interesting that we start to lose track of how they're created because they're being created by the machines themselves. And that leads to a compiled output program. And that output program, when you give it photos of cats and dogs, can correctly identify what it's looking at every single time. This is sweeping again across all these different industries. We're seeing it everywhere. The more you hear about it, the more it's coming up in everyday conversations about everything we're going to be interacting with. This is absolutely one of those things that's going to be embedded in every single environment that we get to. And when we talk about this from a functional testing perspective, let's talk about how we've embedded it into UFT. So the exact same example, but now we've changed our script. Our script is now using these AI util commands. So we've built this as a separate software development kit that's embedded into UFT, but is a separate engine because we plan to embed it in multiple other products as well. And you can see that there are multiple different Android and iOS devices we're going to run this particular test on. So when this test kicks off, because we made the change to the Android phone where we switched the context of the hamburger menu. And the hamburger menu is a term that people use to describe that ellipses menu with the 3 bars on it. Kind of looks vaguely like, you know, bun, burger, bun. So now it's saying, okay, I can see there's that button. I'm going to see there's a profile button. I'm going to click that. I'm going to set my username, set my password. You can see that username is actually misspelled in my script. It says username. Good enough for the AI engine. It understands the context of what I'm talking about, and it's doing a little bit more and going into the search and looking for different things in here and adding something to the cart. Then it's going to play this again on an iOS device. We'll see the number of buttons change on the device. There's just the one for an iPhone, but now the menu is on the opposite side of the screen. This does not pose a problem for the UFT AI model. It just is looking at the screen and analyzing what's going on with this. So at playback, I've added this incredible layer of resiliency to my test execution, to my scripting, to my script's ability to understand what it's looking at on the screen. This is really fundamental. There is nothing in the object repository in here. And you can see when it's pulling this up that there are, you know, you can see this is what I clicked on, but it's got a score, a match of essentially 100%. And here it's a 96% match that it's seeing because it's identifying that I think it's the same thing, but it moved to the other side of the screen. I'm reasonably confident this is the right thing to click on. So let's use another example. Now on web, we've recently released UFT 15.1 that came out last month, I believe, and this now supports the web environment as well. So we're going to go into a web environment, and we're going to play just another little example script here where we're going to look at some setup functions to set the context, but how do we create these scripts? Well, there's a number of different ways we're going to do that. So first, I need to go and see if the hamburger menu actually exists. And I can do this by simply just typing using context-sensitive help. And if I know the terms that I'm looking for, let's check and see if that exists. You know, if it's there, great. Then I want to click it. .click. That's going to be my first command. I can also create these using the object spy. So if you're familiar with UFT, you've seen the object spy. But now at the bottom, we're seeing the AI object that it identified using the AI engine. I could just drag that into my script and drop it in there. There is also an inspection tool that I can use. You can see an AI button on the toolbar over here. So he's going to click the profile button, click this, and inspect the screen. Give me the screen. What do you see on the screen? Here are all the objects that it's correctly identified on the screen. So it can see there's a username field. It can see there's a password field. It can see that there is a login button, even though it says sign in at this point. I'm just going to grab text. Grab the name of that. But what if I needed other buttons? You know, it identifies search, it identifies the profile, the shopping cart. What about all the text on the screen? How do I identify that? Well, I just change it from a visual element to a text element, and now I can see the forgot your password link. I'm going to look for that text and click on it. These are options that I get from this engine. And of course, it's a command, so I have to actually put in the value that I want it to type as it goes through that. It doesn't know that. This isn't a complete fix. Now that I have this, it's going to run this across multiple different devices. So first, Chrome, it's going to go, and there is no menu for it to click on, so it just clicks the profile button, logs in with the username, the password, and clicks the sign in button at this point. Then it's going to go through and do it again, now on a mobile device, but now it has to click that hamburger menu at this point. Mobile tends to be a little bit slower, and now it can see the profile, type in the username, type in the password, and click the sign in button. Critically, there is nothing in the object repository for me to maintain. There's no complex work that needs to go on in here, and I can see when I look at, for example, the username field, it found both of these things without any issues over here. Here's the username field that it found on the first run through, and here's the username field that it found on the mobile run through. If I look for other fields like sign in over here, I can see that here it found that sign in button. This is what we recorded from, but on the mobile device, it actually doesn't say sign in at all. It says login. And this is because we understand what a login form looks like. in the context of a field called username and a field called password, that next button on there is almost certainly the correct button that we should be clicking at this point in time, even though it doesn't say sign in, it says login. And this is because our AI engine, with the training data that we provided it, understands the context of what is the difference between a sign in button and a login button. There really isn't any at this point. So that is sort of the change that we've made. This is currently available in UFT 15.1. If you are on version 14.53 or later, you have access to the AI functionality. It is certainly part of your existing entitlement. This is not something you need to purchase from Micro Focus. If you work at an organization that has UFT, you have this capability. I would strongly encourage you to upgrade. Another key point is that you can mix the AI commands with your traditional object recognition scripts. There's no reason you can't have some parts of the script be AI focused and some parts switch back to traditional object recognition. This is done specifically so that you can do things like maintain and update scripts when they need to change to begin including AI functionality. In some cases, there may be a lot of functionality you've written, and we want you to be able to take advantage of all of that previous work that you've done while still being able to gradually layer in and transition away from the old style of object repository. This is absolutely going to be the strategic direction for UFT1 going forward, but there are not going to be any changes made that would somehow invalidate all of the work that's come before. We have many thousands of customers with many tens of millions of UFT test scripts. We cannot take any actions that would jeopardize any of that work. So please don't be concerned about that. So this is all what we like to talk about as phase one of our journey on this AI path. There are a number of different directions that we can go down this particular thing. The next major leap that we're going to make is probably in the November-ish timeframe. Not a promise of a timeline, but that's the current plan, where we're going to introduce the idea behind natural language processing. And NLP is really this idea that if I needed to search for a dog in Google, what exactly would I do? What are the steps that I would follow as I go through this? Well, first I would need to open up a web browser. Then I would need to go to google.com, assuming it's in not my default homepage, or google.ca for me. Then I would need to type in a search term, dog in this case, click the search button, and maybe switch to the image search tab. There's a number of discrete steps that need to take place in there. And that, like all of the previous UFT examples that I've been showing, are very obviously a script, a set of steps in a particular order that need to be executed in that order. But what if I could just tell the tool, search for a dog in Google, and it would understand the 5 steps that it needed to take to actually accomplish that task, and do that just based on that one-line description of natural language text? This is the next major innovation that we're heading towards. This would also be transformative because there's no object repository or other programmatic structures that we need to worry about. We could then start building scripts that are fully automated just by importing existing manual test cases in a lot of scenarios. So we're still in development for this. It's coming along, but it's a very fascinating space that we're heading towards that would give those business analysts, those people who really have that understanding of the application, the ability to simply write out using natural language what they want to have happen and have the automation tool deliver on that. And this is, there's so much to think about in terms of the scope of what this means as we're going through that. So let's talk about those specific benefits that have come out of this. We have many customers who are already journeying down this path and starting to see these benefits that I'm about to talk about. These are being quantified by our customer base. So the benefits that come out of this, the reliability of the script goes up sharply, as long as the general appearance of what it looks like on the screen isn't changing substantively from release to release, coming out of a very fast, agile, and DevOps process. The script continues to function without requiring any maintenance. It just works every time you want to play it back. This makes it substantially more reliable to include in your CI pipelines. There's been a lot of pushback from development teams about putting functional test tools from traditional solutions like UFT into the pipeline because they just fail on every new build. That tends to just go away. We've seen a lot of our big customers starting to implement this very, very strongly in the development space, taking advantage of all those QA assets. We have seen automation coverage, which was very skill barrier limited, start to explode. Because we have this ability to provide this capability on your existing licensing without requiring any additional purchase, all of a sudden the number of people who can participate in the AI conversation goes up. And because the scripts are much more reliable, your script execution times tend to also dramatically increase as well. And what we're seeing at a lot of our customers is not a need for new licenses, but rather much more use out of the existing licenses they already have. We're seeing a lot of customers who would see UFT being used for possibly 10 or 11 hours a day, where it's 8 hours a day open on my desktop as a UFT automation engineer, and I'm building my test during the day and doing test runs to validate that, and then a couple of hours as part of an automated build process overnight, to 15, 16, 18, or 20 hours of execution time because the scripts are so reliable. And those licenses are seeing much more extensive use at organizations, delivering more business value on the investment you've already made, which is great. And then the maintenance costs. We've seen reductions of anywhere from 70 to 95% of the maintenance cost being reduced or otherwise eliminated from the existing script assets that people have. Things change, you need to go in and tweak and tune those. Certainly frameworks and proper structure of your automation assets to reuse functionality like a login process can mitigate a lot of this. So you change login once and then the 200 tests in your suite are all updated because they have that shared component. But now you don't even need to modify the login component. There are any number of benefits that are coming out of this and dramatically simplifying things beyond even just the scope of there's just no object repository to deal with anymore. Execution time also, this was the major axis of our investment. We figured out how to get it to look at the screen and understand the objects quite a while ago, but getting it to do so in basically the time frame it takes you to blink your eye is sort of the benchmark that we were going towards. We're about 10% faster than 10% slower than we'd like at this point. So it's like a noticeable beat, but it is very, very fast. You wouldn't notice generally any substantial difference in your script execution time. So there is always then that concern that comes up about what is the context of how this is going to work and what are we going to do on this? Is it going to derail a lot of our script execution times? We have not seen that at any of our customers with their extensive pipelines. As I said, this is all, the current version is 15.1. Basically, you just need to update to that version. If you're current with support, you're allowed to do that at any point. And as I showed, it will work across multiple devices. We're focused on web environments and mobile devices at the moment, but we are gradually introducing more and more environments to this to begin to supplant all of the object recognition from all the other UFT supported environments. And eventually we plan to narrow down to just supporting the AI engine because all of the other engine types would be superfluous. That is possibly a decade in the future. Certainly I would recommend starting to investigate this. It's great, it works extremely well. When we get through this use case of, hey, I needed to have 3 different scripts for this, but now I can just say, no, I just need one script and it works across web and mobile platforms. And I can now use the existing UFT assets that I already have with concurrent licenses to do parallel execution of these. I don't have that script maintenance that I've introduced onto the model. There's any number of benefits that come out of this. So there's a huge increase in the value of UFT to your organization. Now, there have been a couple of additional questions that have popped in. I kind of talked about some of them. The next release of UFT, where we begin to introduce the natural language processing capabilities, is scheduled for the November timeframe, I want to say. But 15.01 came out last month. It's been very well received so far, so I would encourage you to use it. All of the AI capability has been in our products for about a year, starting with UFT 14.53. So if you're not aware of it and you are on that version, you can begin to experiment with it. But certainly the newer versions are substantially more capable than what was in 14.53. A lot of additional work has been done at this point. And then running tests across multiple devices is done just like any other UFT data parameterization exercise, whether you're using different web browsers or different mobile devices, or you are using a proper test structure through something like ALM or a CI system like Jenkins. You can distribute the testing across a wide variety of platforms and organize it that way. So that's the end of my content. I would pause here to see if there are any additional questions that anybody would like to ask. Again, if you want to come off mute, by all means, please feel free to unmute yourself and ask away.
That's a great session, Brian. Folks, if you want to ask any questions, please feel free to come off mute and ask any questions, or you can also type away your questions in the chat box.
All right. While we wait to see if there's any questions that come up, Vijay, I'll turn it back over to you.
Thanks, Brian. So while we are waiting for the questions, let me introduce you to one of the other features of Vivit, the Espresso Talks, the podcast. So you can join the Vivit Espresso Talks for short, bold, strong conversations on our podcast channel. You can find the link on the Vivit website. Here are just some of the episodes already covered. Check out Vivit's community calendar on our website to see all the future scheduled events. So these are some of the episodes that you can see it on the screen.
Oh, sorry.
Yeah.
All right, there don't appear to be any questions at this point.
Yeah, that's a great session, Brian.
It's very transformative. We're fundamentally altering the concept of how functional testing has worked over the last several decades at this point. So it is, we always talk about the, oh, this is the next big thing or whatever else that we're doing. It is really legitimate for one of the first times. I often talk about, much to the chagrin of many of the other product managers here at Micro Focus, this is the single most impactful thing that we are doing within our portfolio. It is absolutely going to change things. A great question from Radha just popped in as well. Because we built the AI engine as an independent SDK, we are going to be putting it into UFT Developer, which is the new name for LeanFT. That is going to happen in the November timeframe. So starting in November, with the November release of UFT Developer, aka LeanFT, it will be capable of the AI recognition.
Thanks, Brian.
No, and David asked a question as well. Is there's no performance drop-off? There is not, none that we've seen. It is probably about 10% slower than a traditional object recognition script. A little bit less, somewhere in that that range, but that is not a noticeable difference. You're talking about, you know, a script that takes a minute to run, taking a minute and 6 seconds. It doesn't traditionally have a dramatic impact. Most of the customers that we've seen going through this with their many thousands of tests and their regression have noticed, again, lots of hours of difference there, but the reliability difference is well worth it in their estimation. Any other questions that anybody would like to ask? All right. Traditionally, how these types of webinars work, about 20 minutes from now, you will think of 7 questions you wish you had asked while you were on the webinar. That is great. We're happy to get those questions. By all means, please feel free to reach out to the Vivit community, whether that is Vijay or Terry or myself. You can reach me at brian.cole@microfocus.com. Brian with an I is a nice gentleman. He does not want your email. We are, again, here to help. if you do have questions at any point, we're happy to connect you with your local sales team. They would certainly be able to help you. If you're based in the Toronto area, that would be people like Dean Nellis or Rob Platt, or your local pre-sales team members, whether that's Alan Levson or Alex Gabriel. Certainly myself, I'm local here in Toronto. I may have met many of you before through my various interactions at customers across the GTA, but we are absolutely, if you do have any other questions, here to address those.
Thanks a lot, Brian. So this event has been recorded and the link has been shared, will be shared across on the Vivit website. We will invite you to actually look at the recording. Anybody who might have missed this, or if you find this presentation interesting and you want to forward it to your friends, colleagues, and would encourage them to look at the presentation, that will be great. We'll send you this particular link shortly. So Vivit, let me answer that question. Vivit is not exactly a part of Micro Focus, but it is an independent organization which is mostly supporting the Micro Focus with various questions. Brian, you want to add anything to that?
Yeah, it's an independent collection of basically a not-for-profit organization designed to help customers of the Micro Focus tool stack across both the testing as well as operations and security and mainframe and whatever else, connect with one another and understand how they can learn lessons from others in their peer group. And certainly Micro Focus endorses it and tries to help out whenever we can. We're happy to speak to our colleagues here in the Vivit community to help you get more value out of your existing technology investments.
Yeah.
Any other questions that anybody would like to ask? All right. Well, and then we will conclude the webinar at this point. Thank you, everybody, for attending today. As always, if you do have questions, please don't hesitate to reach out. We are always here to help. Have a great day, everybody.
Thank you all.
Thank you.